Hello everyone, today we're going to be going over some Blind 75 C++, and today we are going to be focusing on meeting rooms. So, before we get started, to break down every single problem, let me just put this up. Alright, so we have interval. We need to ask ourselves what the input is going to be. What data structure / algorithm / technique we need to use. What to do with the data. And then what our output is going to be. We need to answer all those questions, all four of them, so that way we can break down and understand fully. Because sometimes there are going to be some questions that are going to trip us up, as usual, in said interviews. Alright. So, to be able to go over the question, given an array of meeting times, intervals, where interval I equals start I, end I, determine if a person could attend all meetings. So interval, we have array of intervals as even indicated by right up here in the parameter. So let's go over the example. Example, we have interval of 0, 30, 5, 10, 15, 20, where intervals I equals start I, end I, determine if a person could attend all the meetings. Well, the question is, can the person attend all meetings? Okay, so to be able to give a rundown of this whole thing and to be able to break up the question is that, so if we have intervals in particular, so the meeting is going to be starting at this time and then ends at this time, starts at this time, ends at this time, starts at this time, ends at this time. As a result from this, given the fact it's overlapping the other times, therefore it's going to be false. But then, for example, 2, we have 7, 10, 2, and 4, where it looks like it's just for 3 hours over here, and it looks like it's 2 hours over here. They don't overlap, so it's going to be true. Okay? So, to be able to go further down over what we will use, the data structure we will be using is going to be a min heap, which is built using a priority queue, where that is the principle of last in, first out. Much like in the grocery, no, it's first in, first out. Sorry on that. Priority queue, or queues in general, is first in, first out, much like in the case of the grocery store, for instance, and shopping cart. That's the best way of metaphorizing it. And so what we will be using this to sort the intervals. Alright, here we go. And then we need to ask ourselves what to do with the data. Okay, so what we need to do with the data is first sort the intervals based on their start times. Then we will iterate over the sorted intervals, adding each interval to priority queue min heap. Okay, just clean this up. Alright. If the start time of the current interval is greater than or equal to the smallest end time, the root of the min heap, we can use the same room and pop the end time from min heap. Alright, here we go. Right over here. And finally, we're just going to output whether all the meetings can be attended or not. So to be able to give a rundown on this whole thing, we're going to focus on step 1. Again, intervals. And right over here. Then we're going to have step 2 where we're going to create a priority queue. Int vector int greater int min heap accordingly right here. Okay, such as we have our following vector of our int here, and that because a priority queue typically has 3 different parameters on the inside. Now we're going to iterate for auto and intervals. Checking to see if it is not empty. If the min heap is not empty and the interval at the very first index is greater than or equal to the min heap at the top, we're going to pop it. It behaves similar to a stack, but then we have other characteristics of the min heap. Min heap dot push. We're going to push this inside interval the next index. One will return false if min heap size is greater than 1. We're going to return false in this case is one of the edge cases, and finally by default we will return true. That's because we are comparing the different sides of our following heaps inside of the following interval that we have. So just going to check to see if everything already matches up. It passes all the test cases. Let me clean this up for you folks. Submitting it. Alright, and it works. So to be able to give a rundown and break down everything that we have, the time complexity for our following solution is going to be O n log n, where n is the number of intervals, and due to the sorting step in the beginning that we have, since we have different intervals on the inside of the whole intervals array, that would explain what we have, and then given the fact that we're using a data structure of a queue, the space complexity is going to be O of n, since we need to store all of the intervals that we have visited and compared. But overall, just the storing aspect is going to have a space complexity of O(n). So yeah, this was meeting rooms in C++, Blind 75. Thank you again for taking time to watch this. If you found this helpful, feel free to like and subscribe. And if you have any questions, put them in the comment section. And as always, take care. Cheers.